In this video, I'm going to demonstrate how to conduct a 2x3 factorial between subjects ANOVA. And the example study is the video game study. Now I've changed these data a little bit because I've ensured that the sample sizes are equal across all the groups in order to simplify the issue of heterogeneity of variance. I talk about that more in the advanced topics section of the chapter. So you would analyze the data exactly in the same way that you would for a 2x2. The complicating factor is if you get an interaction, you then have to decompose the interaction effects. So you would analyze the data pretty much in the same way that you would for a 2x2 between subjects factorial ANOVA. So you can go into Analyze, General Linear Model, Univariate, put the punishment variable in the dependent variable box, and game, type, and sex in the fixed factors box. I'm actually going to click on Options and get Descriptive Statistics. You always want effect size. Homogeneity tests. Whether you want power or not is up to you. You can click that if you want it. Click Continue. I do want the estimated marginal means just to have a complete analysis in this case, and also it would allow me to test for differences between means across the independent variable with 3 levels, which now is video games. So I'm just going to ask for the whole thing. Click Continue, and that should be enough. Oh, I actually want to plot things just to show you what you're going to get here. We're going to look at the game type effect, the sex main effect, and also the interaction, which I'm going to put game type on the horizontal axis and sex as separate lines, and add that to that. And I'll include error bars just to see what it looks like. Click Continue and click OK. So here are the results. I've got the between subjects factors table, which is essentially a representation of the design with the sample size, and I'll improve this a little bit by pushing that out. There we go. So I've got game type, and there are 3 different game types: violent, non-violent, and control group. The sample size is equal across all 3 groups. And then I've got males and females, and that's also equal sample size of 24 in each. And that's the 3x2, otherwise known as a 2x3 factorial between subjects ANOVA. Here are the descriptive statistics, and these are known as the observed descriptive statistics, and we can see for the main effect of video game type, which is a violent video game, non-violent, or just watching an animated program, which is basically no video game, we've got the main effect mean of 6.01, 4.79, and 5.60. So those are the observed means associated with the video game main effect, and of course the standard deviations are also next to those means. Now for the main effect of sex, those means are right here, 6.17 versus 4.77, and here are the standard deviations, and here are the sample sizes. Now the interaction would be based on the means of male-female violent, male-female non-violent, and male-female control group. Now again, these are the observed means, and also what's going to be reproduced later in the tables are the estimated marginal means. Here's Levine's test of homogeneity of variance, and if we focus on the based on mean row, we have a Levine statistic, which is an F value 5.88 with 5 and 42 degrees of freedom, which is statistically significant. So the assumption of homogeneity of variance has been violated, but because all the analyses that I'm going to do has equal sample sizes, so for violent, non-violent control, it's all the same sample size of 16. For the main effect of sex, it's a sample size of 24 equal. And then for the interaction, it's going to be 8 across all cells. I'm not concerned about the fact that I violated the assumption of homogeneity variance in this case, because the sample sizes are equal. Now here is the core of the analyses. You can ignore corrected model row and intercept row. Check out game type row, and we can see that an F value of 3.816 with 2 and 42 degrees of freedom was statistically significant, p equal 0.030. and a partial eta squared of 0.154. So we rejected the null hypothesis of equal means across these 3 totals here. We don't know which ones are statistically significantly different from each other, because now we have 3 means rather than just 2. And that's why I clicked on that Fisher's LSD option in the estimated marginal means utility. I'll check that out in a minute. Then we have the sex main effect with an F value of 14.39 and 1 and 42 degrees of freedom, also statistically significant. And so this male mean is statistically significantly larger than the female mean. Now what's complicating the interpretation of the main effects is that the interaction, game type by sex is also statistically significant, p equal 0.049, based on an f value of 3.25 and 2 and 42 degrees of freedom. Here are the estimated marginal means: 6.018, 4.79, 5.606, and we can see that they're actually exactly the same thing as these means here. So it's come out. Let me just actually take a snapshot of that. So we've got 6.0183, which is 6.018, and we've got 4.791, and then we've got 5.606 and 5.606. So in this case, the observed means are actually the same as the estimated marginal means, which is going to happen when the sample sizes are equal. When they become unequal, then the estimated marginal means become different, and technically the ANOVA is based on the estimated marginal means. In this case, it should be the same. So here is the post-hoc testing associated with the main effect of violent versus non-violent and control group. Now I still don't know if I can interpret the main effect because there's an interaction. But let's just say I decided to interpret the main effect. Then this is the table I would consult, and we can see that violent video game playing punishment mean versus non-violent was statistically significantly different. And the violent versus and control group mean, however, was not statistically significantly different. So this mean was statistically significantly different from this mean, but this mean was not significantly different from this one. And then finally, the difference between non-violent and control group, non-violent control group, was also not statistically significant. It was getting close to 0.05, but it wasn't. So I can't say anything about the difference between these two means, except that I failed to reject the null hypothesis. Now if I keep going down, I can ignore this table here because it's essentially redundant with the information in the overall table. Here we have the estimated marginal means for sex, which again should correspond to the means reported in the descriptive statistics: 6.172, 4.77, and yes, we've got exactly the same means here, again because we have equal sample sizes. Now this test here is really just a redundant test based on the ANOVA, because this test of the difference here for sex is actually only based on two means. So this f value of 14.394 is essentially the same as the t value that's not being reported here. Let's just verify that. What do we got? 1.401 divided by 0.369 equals 3.79. So if I square that value, 14.41, and the main effect for sex, 14.394. So within decimal places, it's exactly the same result. So this sex main effect analysis here isn't really informative when you only have two means, because it's exactly the same test except within an ANOVA F framework rather than a t-test type framework, which is done here. But when you have three means, then these extra analyses are valuable. Now still, I don't know if I can interpret the main effects because there's a statistically significant interaction. The observation, of course, of a significant interaction does not necessarily preclude the interpretation of a main effect. I would have to do simple main effect analyses in order to evaluate that possibility. Also look at the interaction chart here. So this is the interaction effect that looks like it's going to need some work to interpret. Now, when you have something as large as a 2x3 and larger, you don't know where the interaction is happening. My hunch is that there is a significant interaction going on here, which is helping to push the interaction effect to be statistically significant. It's just barely so, but I don't know exactly where the interaction is happening. Is it happening here? Is it happening here? Or is it happening between these two means and these two means and ignoring these means? I don't know. As I mentioned in the textbook, you need to follow up a significant interaction when a design is equal to 2x3 and larger with a series of 2x2 factorial ANOVAs, which I'll do in a separate video. The last thing I'll do is I'll show you how I created the chart. This is not really how I would prefer to show an interaction effect. It's not wrong, but it could be improved by looking at it in a graph. So if you go into Chart Builder, click OK, And then we want that sort. We want the clustered type of bar chart. We want to change this to a mean. So I'm basically creating the figure that I show in the chapter of this section of the chapter. And then I want game type on the x-axis, and I'm going to put sex on the clustered part. And I'm going to get the error bars. And then I click continue, and here is the bar chart. Clustered bar chart doesn't look like what I actually reported, but it is the result. Let me just clean it up a little bit. So we have here, it needs a little bit more work in order to make it look like what I showed in the in the textbook. But you can see here that the difference between males and females for violent is quite a substantial difference here. And then the difference disappears at nonviolent. This is essentially the same result I was shown for the 2x2 between subjects factorial ANOVA. This is the additional level that I added for this analysis to make it a bigger factorial ANOVA. And that's the control group. And you can see that the males are scoring higher than the females. I know this is going to be significant because the 95% confidence intervals are not intersecting, not even closely so. And so that's why I describe in the textbook that it would have been vital to have a control group, arguably, in the Bartholow et al. Study, because it's possible that the violent video game isn't potentially causing males to be more aggressive. What might be happening is that the males just displayed their natural level of aggression as measured in the violent video game groups, because that's what they're basically producing here in the control group when they just watch an animated program that is not particularly violent or anything of its nature. It's just a neutral type of animated program. And so I make the suggestion in the textbook that possibly what's going on is not that violent video games cause males to be more aggressive. It's that males become less aggressive when they play a non-violent video game such as golf. And so that is a very vastly different interpretation of these data. And the only way I could get a sense for that is by including an actual control group in this design.